Line 22, 7B112 Higgs proton particles mass Atlas CL dark matter formula Wow Seti. There's the alien radio signal, and this is a quote from a blog. Now this says it's a long video, so the keyword research on Higgs boson proton particles with formulas in them, okay? So quotes are from a blog. This is the Atlas preliminary. The Higgs particle analogy for physics classroom. Let's get rid of that. Okay, comparing refractive index and mass when light composed by photons passes through a transparent material such as glass, its velocity changes according to the refractive index of the material. So it shows it there. Okay, December 8th, my thoughts. The Higgs passes through graphite film particles in a superlattice wall. Quotes from blog. This slowing is caused by the electrical fields in the material. When the beam of the light enters the material at an angle, it is bent or refracted as a result of the decrease in velocity. My thoughts. Refractive index, slowing energies to ultra cold atom particles as they rotate the proton energies around the wires and nodes in the UFO engine core structure, creating a magnetic force pulling with the four quadrupole magnets plus two monopole magnet structures. Quote from blog. The reason why photons are slower when they pass through a transparent material such as water or glass is the effect of the electrical fields surrounding the electrons and nuclei of the atoms in the material. My thoughts. The water vapor communication invention found in line 22 while data formulas and convention keyword research can be used with this. So we'll do cross-reference. Cross-reference lines 1 to 27 for water, vapor, and communication. Yeah. Formula idea from the data. The photons are slower plus transparent crystal wafers, material, water, glass, obsidian, glass mirrors, effects of Higgs electric fields. Surrounding electrons, electron holes creating quantum dance and particle superspeeds processing, nuclei, atom cloud in material. Atom cloud particles in the superlattice wall material with a combination of superalloys, bendable flexible metals, copper to copper, and then we've got rotating carbon nanotubes. I'm going to add there. Vacuum chamber and electron hole structures that exist in a hyperbole state. Quote from the blog. When photons go through a transparent material like air, the interaction with the electrical fields of the atoms there is smaller because they are so far apart. Nonetheless, when they pass through a transparent material like water or glass, the interaction with the electrical fields of its atoms slows them down considerably. Formula from the data. Photons go through transparent material like air, hyperbole space with charged neutrinos and other particle mixtures. The interaction is with the diffraction of laser beams creates jet streams with magnetic resonance inside the Higgs electric field. Between the two superlattice walls, there's an electrical field of atoms and smaller colliding particles congested. Slows down signals in the quantum dance of the particles, allowing them to gain mass. Quote from blog. The fields almost act like a friction on the photons, thus decreasing its velocity of transmission. It is like trying to walk through a muddy field. Formula from the data. Electric Higgs field creates friction on photons, decreasing velocity of transmission. Walking in a muddy field, the mud sticks to your boots equals mass sticks to particles, making them heavier. Heavier are ultra-cold rubidium atom particles in this mixture. Quote from blog. A measurement of how much the speed is reduced is given by the refractive index of the material. As it is known, the refractive index I of a material equals the speed of light in a vacuum C, divided by the speed of light in the material V. So I equals C divided by V. Formula from the algorithm. Refractive index, measurement of atoms, speed reduced in velocity equals the speed of light in a vacuum chamber, divided by the speed of light in the material, visible light, blue. I equals C, speed of light in vacuum, divided by V equals speed of light in the material. Quote from blog. A very important thing that the speed of light in a transparent material is slightly different from each wavelength, i.e. momentum of the photons. For instance, considering visible light in water, blue is 486.1 nm and 1.337. Yellow is 589.3 nm or 1.333. Red is 656.3 nm or 1.331. So yellow photons travel through water faster than blue, and red even faster. Just formula from the data. Speed of light in transparent material. Wavelength, yellow photons travel through water faster than blue, but red photons are the fastest in water. Quote from blog. We could say that blue photons have more problems to move in water than yellow and red. In this way, the blue photons act like as if they have more inertia or more mass. Formula ideas from data. Blue photons are the particles adding mass to other particles, neutrinos. Using blue visible light, you should be able to see this happening at the LHC or CERN testing facilities. Quote from blog. Refractive index gives a measure of the interaction between photons and a material medium through which they travel. But somehow it could be also considered an index of mass, since the bigger the value, the smaller the speed of the photons. Formula from data. Refractive index measure interaction between photons, neutrinos, colliding particles in material medium through the travel vacuum chamber. Index of mass of particles observed, bigger mass value, smaller speeds of photons. The neutrino test CERN 2012 from faster than the speed of light to slower than the speed of light. They added mass in the second set of results when the observations were changed. Quote from blog. Therefore, in vacuum, all the photons travel with identical speed, but if the universe were filled with water photons, corresponding to different wavelengths, would travel with different speeds. Formula from the data. In vacuum, all photons travel at identical speeds. Add water, steam as they travel. Photons correspond to different wavelengths, travel faster or slower speeds. Quote from blog. As has been said before, they would have different masses, so we would be passing from a symmetrical situation to a non-symmetrical one. This is what in particle physics is called symmetry breaking phenomena. Formula from data is different masses passing symmetrical situation to non-symmetrical particle physics, symmetry breaking phenomena. Quote from the blog. Now we are ready to establish our comparison. Initially, all the particles would be traveling through an empty universe with the maximum speed permitted, so they would be all be massless, and from this point of view, the universe would be symmetric. Formula from data. All neutrino particles traveling empty vacuum, maximum speed, speed of light, all its massless, dark matter is symmetric. Quote from blog. This is what SM originally states, but obviously the universe does not work in this way. The current SM suggests that all the particles had no mass just after the Big Bang, just as the universe cooled and the temperature fell below a critical value, an invisible field called the Higgs field appearing, filling all the space. Quote from blog. www.lhc-closer.es. Continues after PDF results below. Formula from data. Dark matter, no mass. After Big Bang theory, universe cooled, ultra-cold rubidium atoms. Volcano explodes with intense heat, cools and creates an island with its dark matter particles, which in turn grow life, organic forms within a certain period of time. So each particle of dark mass has a brain that gives it instructions using electronic pulses to activate the mapping guide inside its DNA. Back to the data formula. Temperatures fall below critical values. Higgs field fills spaces with mass particles. Quote from a blog. We could also say that the Higgs field was born in the beginning of the universe, but it only showed its influence once the universe cooled down enough. Unlike in magnetic or gravitational fields, which vary from place to place, the Higgs field is exactly the same everywhere. What varies is how the different fundamental particles interact with it. That interaction is what gives particles mass. Of course, other kinds of interaction, such as electromagnetic, weak or strong interaction, may contribute significantly to the resulting mass. Moreover, the degree of resistance of the Higgs field is different depending on the fundamental particle, and this generates the difference in mass between an electron and a quark. Now suppose a quark or electron making up composite particles such as proton, neutron, or various atoms in this uniform Higgs field. If these atoms or molecules change their velocities, that is, if they accelerate, then the Higgs field is supposed to be exerting a certain amount of resistance or drag, and that is the origin of the inertial mass. This turns out to be a similar situation to what we have seen above. The Higgs field acts as a transparent material with a specific refractive index for each kind of fundamental particle. So this is the mechanism which provides with mass each different particle, and this index is what physics call mass. According to its index, particles have a different behavior when they interact with each other. For instance, when a proton interacts with an electron, it undergoes an effect almost 2,000 times smaller than the electron, because the index in the Higgs field or protons is almost 2,000 times greater. So this field is responsible for the different masses observed for particles, and it constitutes the symmetry breaking mechanism that explains how our universe works. Despite this analogy being far from perfect, the main idea to take to secondary classroom is to establish a parallelism between the symmetry breaking and the speed of photons and when they travel in a transparent medium, and the symmetry breaking of particles when they travel in the Higgs field. From a quantum point of view, we can only stir up the Higgs field in discrete units. The smallest possible disturbance is due to a Higgs particle, or more precisely a Higgs boson. ATLAS and CMS are general-purpose LHC detectors designed to see a wide range of particles and phenomena produced in LHC collisions. The Higgs boson, possibly hundreds of times heavier than a proton, could be created in the proton collisions in the center of the ATLAS and CMS detectors at LHC. More than 4,000 physicists from about 40 countries are using the data collected from both complex detectors to search for the Higgs particles. I didn't know you had that many people looking for it. Wow. It is widely believed that the Higgs exists, or at least some of the sort Higgs-like particle that plays that role. And that's www.lhc-closer.es. My thoughts. And it was found June 2012 at CERN, the Higgs boson particle. Data continues. So you guys finally found it. That's cool.